Welcome back to Math 3321. We are moving with multiplication and division today. Specifically, we're looking at the division of whole numbers. So you should be able to understand what division means through a few different models. Think about the inverse relationship between multiplication and division. Think about the special cases of division by 0 and 1. Explore some division algorithms, including that standard long division algorithm. And then think about some mental division skills and estimation techniques. So in this video, I'm going to walk you through 3 different models for division with whole numbers. With each of these models, we're going to need to remember some vocabulary that we had with division, which is dividend, divisor, and quotient. So when I say dividend, that is the number that we are splitting up in whatever fashion. So in 12 divided by 3 equals 4, 12 is the dividend. The divisor is the number that we are dividing by. So in this case, 3 is the divisor, and the quotient is the result of the division, in this case, 4. So the first type of division model I'm going to introduce you to is the set or partition model. This is when the set of elements representing the dividend is partitioned into divisor number of subsets. So in this example of 12 divided by 13 equals 4, I would divide 12 into, or partition it into, 3 subsets, and each subset would contain 4 items. The second model of division I'm going to walk you through is the missing factor model. And this is when we might take A divided by B is some unique number C, and we define this division by saying that this A divided by B is equal to C when B times C is equal to A. So in this case, we might say 12 divided by 3 is equal to 4 because 3 times 4 is equal to 12. So I know that 3 groups of 4 results in 12, so 12 divided by 3 is equal to 4. And then the last model I'm going to walk you through is called the repeated subtraction model. So this is when we take our dividend and continually and repeatedly subtract the divisor from the dividend until we have nothing or just a remainder left. So in the case of 12 divided by 3 equals 4, I would say, all right, I have 12. I'm going to subtract 3 from that. That leaves me with 9. I'm going to subtract 3 from that. That leaves me with 6. Subtract 3 again. That leaves me with 3. Subtract 3 again. I have none left. So I've subtracted 3 from 12 4 times, which means that 12 divided by 3 is equal to 4 because I was able to make 4 groups of 3. So here are some more formal examples. If we look at the partition model, suppose we have 18 cookies and we want to give an equal number of cookies to each of 3 friends, Bob, Dean, and Charlie. How many should each person receive? So we could model this with an equal groups model and take each cookie. We would have our 3 sets for each of our friends. And then we could, the action of this partition model is to say, okay, you get a cookie, you get a cookie, you get a cookie. And then you keep divvying out or passing out like you would with playing cards. You give each person a cookie until you run out of cookies. So each person gets a total of 6 cookies, so 18 divided into 3 equal groups gives us 6 in each group, so 18 divided by 3 equals 6. With that missing factor model, so again, if each friend receives C cookies, then the 3 friends will receive 3C or 18 cookies total. Therefore, 3C equals 18. So we would look for, in this case, the factor that multiplied with 3 gives us a total of 18. So we could think about this using multiplication instead. All right, so we're going to define division for any whole numbers A and B with B not equal to 0. A divided by B is C, if and only if C is the unique whole number such that B times C equals A. And again, A is the dividend, B is the divisor, and C is the quotient. We can also write division a couple different other ways. So we could write it with a fraction bar. A divided by B would be illustrated with A over B, or with kind of a long division, a house, some people call it, B dividing into A.